Da, da, da. Okay, I am back. Let's wait a little bit, see if it's actually any better now. Da, 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 da. Font's a little small now, okay. Gotcha, yeah. Oh man, this is... So for me, the font is far too big. When I'm looking at the screen, it's insane, right? Is that any better, Megan, or... Yeah, is the font now okay, or is it still too small? Okay, cool. Right, so where were we? Okay, yeah, testing the linker. So yeah, so I repurposed stage 2 tests a little bit in the sense that instead of relying on the build system, we... Okay. Oh yeah, it is 4 a.m. for you, that's true. Yeah, crazy. Crazy hours, Megan. So yeah, I guess good night then. Right, so repurposing the stuff here. Yeah, so instead of relying on the build system, we actually do everything kind of by hand by invoking the child process. In this instance, I guess, because of there's a note in stage 1 that it leaks a lot of memory. You know, the one written in C++. Stage 2 obviously is a lot better and actually has got no memory leaks, or far fewer at least. So when we hit the stage 2, being actually a little bit more stable and complete, I'll switch to actually plugging into the stage 2 directly. Yeah, thanks, Bennett. Yeah, thank you guys. I mean, it's very helpful. You know, as I said, like, I don't have any feedback for this, so it's very difficult for me to judge if it's visible, you know, clearly and stuff. So yeah, if you have any more feedback, just please let me know, and I'll be adjusting as we go. Yeah, so the build system actually, so the test harness now is it's pretty clean. It's pretty simple. What we do, basically, we create a case, and we add an executable to it. There is a check later on that, you know, we only expect one executable. I don't even know what you would do with two, to be honest, because obviously, I mean, why? However, you can also create a shared object, and, you know, on macOS, because we're actually talking about the macOS, the Maco back in here. There will be a dilib, and then you can actually declaratively link it with the executable. Linking here in this way is actually not specifying a system. So basically the -L on the linker line, this is actually linking in directly, like, with an absolute path to the shared object. So it's slightly different. You have to tweak the rpaths. If you do that, you have to specify in the executable. Kitty. So I heard about Kitty. Oh, it is faster. Oh, sweet. Oh man, I'm gonna definitely give it a try. I read some good stuff. Actually, I wanted to try it, and not because it's faster. I wanted to try it because I was kind of disillusioned with the entire thing about Electricity. There was this massive, I think, GitHub issue maybe, that somebody was not very happy with how the nothing is like, everything is stalling, nothing is getting in, things aren't properly worked on and stuff. So it's definitely on my to-do list. I might do that actually, because I hate the default terminal on macOS is it's pretty slow. I don't like it. I tried the iTerm, but it does everything in a different way. Yeah, exactly. Development is quite yeah, that's very sad for Alacrity, I guess. But for me it's not slow. It's just it's got different bindings for everything, and I just get lost. I use Tmax, and I use Tmax on every on Linux and macOS, and I want my Control B, like the key bindings, Control B C and so on and so forth, actually there, and with Tmax that was gone. Right? It's crazy. It's like, the Command T, I was like, I don't have a command. Like, I don't want to remap my keyboard every time I switch to Linux or something. That's just ridiculous. So yeah, I feel you there. Yeah, I'm definitely gonna give Katia a try then. Cool. I'm actually gonna open a tab right now, just not to forget it. There we go. Sweet. Nice. Right. So yeah, so here we go. These are the tests. The funny thing is, when I was writing the test, and I started I think a week ago, maybe a week and a half, because I had some bugs piling up as well for the upcoming 0.9 release. Oh, by the way, guys, 0.9 is gonna be huge. Like, we have added a lot of features. Linker itself is much more feature complete now. You can actually do a lot, and I mean a lot. If you guys had the chance to watch the ZLD linker demo on Handmade Seattle website, all of that stuff is actually, it will be available by default on 0.9, except obviously the incremental linking, because that's dependent on the stage 2 compilers. This is still an ongoing effort, but sticking in zigcc or zigbuild exe to use the Zig LD as the default linker for C in, for example, Rust should be good to go, to be honest. And here's the link if you guys want it. So all of that stuff is gonna be with 0.9. I did fix 2 more issues here, but they might appear. If they do, then you'll need to grab Nightly, but they're quite obscure, so hopefully they won't. One of the obscure things I fixed yesterday, and I had no idea that something like this would actually work at all. And I don't know if you how knowledgeable you guys are about thread local storage. So we're looking at this case here, the TLS. So we have a very simple dilib that basically exports single 32-bit integer as a thread local. And then we have a very simple executable that basically imports that and then just prints the value. The value should be set to 0 because we don't have any initializer. So by default, the linker should set that to thread BSS, which is equivalent of BSS section, but for thread local variables. And that should be 0, right? And then it turns out that actually this needed another feature in the linker that I had no idea it existed, even because every single example that I reversed to get the macro back and going didn't have it, because it turns out Apple is optimizing stuff away. And actually, no kidding, but if you guys if you're on Monterey on macOS on ARM64 and you link something with LD64, you're gonna get a totally different result to what we are doing, because Apple has again updated how they do stuff. They repurposed a lot of sections. Some of the sections are gone. Some of the sections have different data in them instead of like pointers. So actually having 8 bytes, that they actually specify offsets from that cell into something, further on, different like rebinding stuff. So, hi Raphael, you're raiding with a party of 44, nice. Dry raid, yeah, hello, hey. I watched your stream the other day. It's pretty cool. I think you were doing what's it called, the Smash debugger or something. So working your way through Dwarf. Right, yeah. So yeah, if you're interested, I'm gonna do a stream. Obviously not today, but I have it on my to-do list of implementing something like a DCMutil from scratch. It's not gonna be a DCMutil per se, because I won't be taking exactly objects and just like from the command line and then outputting a DCM bundle. But this is needed for incremental linking in the stage 2 compiler, because we don't have an object file lying around. We do everything in place. So obviously, I could repurpose part of the binary and actually have the information from the object file there, but then the stub entries in the symbol table, I'm not sure if the LDB would actually like it. So what my current plan is to do something like a DSIM util on the fly. So basically create the DSIM, like the debug symbols, a binary mirror of the binary on the fly, and then update it there with all the relocations to Dwarf handled as well. So I'll definitely be working on this. I don't know when yet, but it's happening. And if you're interested, I'll let you know. So this is going to have a lot of Dwarf in it. Okay, right. So where were we? Right, yeah, the thread local stuff. Yeah. So this bit here. Yeah, sounds funny. I know what you mean. Yeah. Yeah, and the funny thing is, just before your stream, I was fixing stack traces in Zig2 on macOS, because the way we were doing them was tailored specifically towards how LVM's LD, and ironically ZigLD2 is laying out the binary that we do. Like neither Zig nor LVM are actually changing the ordering of atoms, so the subsections within sections, but LD64 is actually much more clever than this, and they actually do reorder atoms for locality, which means that the order that things were in the object file and how the dwarf is laid out is not the same as the atoms are in the final binary. So pulling the dwarf like the dwarf mapping from the binary to object files needed some different handling there. So yeah, it's fun times. Right, and back to the thread local. This is interesting. Let me actually wonder if I'll be able to show this for anybody that's interested. So this actually requires another section that's kind of similar to global offset table, but for TLS. And as I said before, I had no idea that something like this existed, because Apple is optimizing a lot of stuff away. So reversing a Mako binary basically gives you, the view of what the final output is of LD64. Okay, let's not clean up the temporary directory here. And let's try and build this. So this should build. Oh, by the way, we have a. Ah, yeah, for sure. Well, I don't. Yeah, my dwarf knowledge. Come on, it's not that advanced at all. Like, I'm basically doing exactly what you're doing. Just going through it, going like, huh, and then reading the manual, the spec, and like, okay, so that's okay. Right, so there we go, we have it here. Let's go to Zig cache. That's probably not one. What do we have here? Right, that's main. Okay, perfect. Right. I don't know if you guys know it. There's a tool. Have a good one. Bye, Rafael. There's a tool on macOS called MacoView. It's quite old. It's not very memory efficient. I think it's got like quite a few memory leaks all over the place. Let me open this and then MacoView. Let's open it up. But it's pretty useful, especially for small for small binaries, because you can get an idea of what things are meant to look like and what they actually do look like. You can do some basic just eyeballing, I guess, because you can obviously use auto, which is like equivalent to object dump AS with a little bit of readelf. But this is useful because you can just, eyeball a section and then do a quick lookup in a different place in the virtual address space if everything is properly aligned and if it's actually there, are we pointing to the right thing? So anyway, so for the thread local, in the example, let me pull it up again, we had a dilib that was exporting a thread local variable called a, and then we were expected to import that into the binary. And this requires, surprise, surprise, and I had no idea, this actually requires this fancy section called thread pointers. And this is effectively like a GOT for global, pointers to, pointing at external or global TLS variables. So it's 8-byte aligned, and it's needed, and it's actually synthetic. I have not seen a single object file that would actually define this section. So this is up to the linker to synthesize it like a GOT. It's basically it's almost exactly the same. It requires the same relocation, like dynamic relocation information, like GOT, as you can see here. We're actually importing a from liba.dilib, and the address is 8010 in hex. That's the address of that value here. And then DYLD will actually populate the address of that variable, like basically of a that's imported from liba.dilib when it's actually loaded. And the same for GOT here for the DYLD stub binder. This is a typical one that's actually exported by libsystem, but this one lands in GOT because it's not a TLS var. So yeah, so this stuff was missing, and because it was missing, it was hitting an assert, or maybe even an error, I can't remember, saying that the relocation cannot be managed because suddenly you have a target address 0. So that had to be fixed. The other thing is that with this fixed, I think, this relocation, this is actually wrong. I need to fix that stuff. This is not printf, this is a. When you deal with TLS on macOS, I don't know why, but you have to rewrite certain instructions sometimes. So this, I think by default, that one in the object file was add. But it has to be LDR, like for load and dereference. Is it? Yes. And the same on x86-64, I think it's fine. It's the opposite way. If you're doing the optimization, you have to rewrite that stuff. Right. Cool. So what I want to do now, actually I had quite a few test cases here already. I'm actually basing the test cases on what Rui, the creator of Mold, the modern linker, did. He's got quite a few test cases, like simple test cases. They're not that complicated. This is not like building a full-scale project. It's not building Chrome or Chromium or anything like this, but they are targeted, they're small, it's easy to debug, and they actually test quite a lot of like edge cases. Rui likes to call them edge cases. So this is pretty good. So I have quite a few, and I added like this morning or last night, I can't remember. I added another one that I want to test, and this is basically the behavior of what to do when it comes to linking system libraries. So we want to create one. Because we have two ways of linking a shared object. We can either specify that as, let me just do some sudo stuff here. We can either do something like, go away. Something like, let's say, I can do it this way. And then have lib foo-dilib, assuming that it's in the same directory here on the linker line. And this is fine. This is going to be treated as a positional. Then we have to add an rpath because it's going to probably have an rpath and the name, and then we need to specify that where to look for it because we haven't passed anything. Or we could do the same thing if we had it if we specify where to look for it, we could do that, right? So two ways of actually linking in a shared object. This one with flags is actually referred to as linking system libs, because that's what you would normally do for system libraries. Like, you would actually do that, and then that would link in the lib system, or libc or libc++, wherever, like LZ maybe. So I want to test this here too. So I want to be able to, in the test harness, create a shared library called foo. So that's going to be libfoo.dylib. Then I want to be able to create a simple executable that should actually, I think, called hello, which I didn't. And import this. Oh, pardon me, I'll be right back. Somebody's at the door. Okay, back now. Sorry, that was the post one. Right, so here we need to call hello. We need to also import this from the dylib. Okay, I think that should be fine. Right, and then I want to be able to do that with the system flag. So basically, I want to be able to point the Zig executable, the compiler, at a library and then link foo as a system lib instead of just passing in it as a positional. Because if we do that as a positional, I think this should work fine. Let's try it out. And this is dylib. So we already have a test like this. So I don't expect this to fail unless I mess something up. But we can have a look. See? Oh, another cool feature is I'm on the M1 Mac. I installed Rosetta ages ago just for testing and things like this. And it's actually a pretty good emulator. It's not bad. It's pretty fast. Yeah, there we go. It passed. So we had an idea, like, well, if we have Rosetta and if somebody has Rosetta and they can specify, like, yeah, I've got it installed, because there is a case that you don't have to install Rosetta, right? I guess you guys know this. On the M1, Rosetta is optional. You get the annoying pop-up if you want to execute an application that's actually written for x86 64 and it's not universal. Then you get a pop-up that, hey, you can install Rosetta. But for example, Andrew doesn't want to have Rosetta in. So he's a perfect test case for me because he straight up refuses to have any emulators on his M1 for testing. But when it comes to like testing, we added the -F Rosetta flag, which means that you can declaratively say, like, yeah, I've got it. And then the test on the M1 will be run for both ARM64 and AMD 64, sequentially. So for the linker as well, we're actually testing ARM64 and AMD 64 linking here, which is pretty great. It's really good. There are things that don't work, and I don't know if we're gonna have time. If I'm not gonna be completely knackered after this session, I can show you that there are some features that are not, I think, emulated well, or we are actually making some mistakes, because for signaling, speaking to the kernel on the Darwin on Darwin XNU, I think. On macOS, we have some signaling issues with signal system call. That it works natively on Intel macOS, but it doesn't via Rosetta. So something interesting, something worth investigating later, I guess. Okay, so this works, great. So now we want to swap this out and see if this is gonna work too. I don't expect it to actually, because I think we need to tweak some of the things. Yeah, that's what I thought. Okay, so DYLD cannot find it for, okay. So that means, I think this is missing from the linker line. Let's have a look. Okay, I need to, so this is fine. Let's comment out everything else so that we can actually have a look what's happening only for that stuff. And link source, that's fine. We actually don't care about cleanup at the moment. We had a build artifact somewhere. Here we go, exe shared archive, cflags name target. Oh, perfect. Let's just dump the args, see what is happening. Okay, so what do we have here? We have the build exe cflags, there are none. Main, not C, name main, that's fine. Target is okay. Oh, and notice that we actually have ranges for the targets as well. If you note here, with Zig, you're able to target precisely the version of the macOS that you want to. And we actually ship like libc headers for every latest version of each release. So we have latest for, what was it, Catalina, right? There was like 10. Yeah, I don't know why it's 13 here. Was it 10, 13? I can't remember. But we have Catalina, we have Big Sur, and we have Monterey. And we compress them in the sense that we do a quick hash comparison, of each libc header, and then we split them up. And if something is actually a match because it didn't change between releases of macOS, we actually put in the same include. We call it, I think, any macOS any, or that's the most generic one that actually applies to every version and every architecture of macOS. And then we have for x86-64 we have a common one, and then for ARM64 we have a common one, and then we have, you know, there's the special ones or specific ones to each version and architecture too. And this is pretty cool. And we also ship versioned text-based definition stab files for libsystem. So this is the stab file that Apple switched to, from actually requiring the linker to link against libsystem.dilib. Instead of actually parsing the binary, you parse a YAML file, and you have all the information there, and actually ship for all three, which means that you don't actually need to have anything on your macOS installed, like no SDK. You don't even need CLT to be able to build and link C, C++, and Zig on like a brand new macOS system. Like if you wiped everything and just use Zig, it's gonna work. Provided that, you know, if you want to link against frameworks, then you have to provide them from somewhere, so that would require you to install the SDK. And if that's the case, then Zig actually falls back to your SDK. So if you want to link against like the latest that we haven't updated yet, then you can do that too. So you can override everything if you want to. So this is pretty cool. But anyway, to the problem on hand. So we do build lib dynamic for shared name foo. So that should be libfoo.dilib. And then if we're gonna go to, what is it? That's x86-64. That might not be very interesting. Let's actually go into, right, that's capital L, capital F, and temp. Okay, right, there we go. Is that actually this is the right architecture? Okay, so it is missing. I wonder why it should be. Is capital L not actually pointing to that folder? Let's see again. So if we do may not see, we don't need a target at the moment because this is native, that's fine. And then right, yeah. Yeah, we need to clean up those tag traces. Like the amount of errors are actually the same as worrying. They should be compressed to just one line. I'll have a look at some point. Okay, undefined reference. Why? Oh, whoops. I ate where? Okay, so I did find it. Oh, am I missing the RPath? Why would I be missing the RPath? Let's have a look at actual load commands, and I don't think I'm going to see any RPath, right? I think it should return. Yeah, okay. And what about the dilib? Oh, that's gonna be, I think, LCID. I think this is where we're gonna have an RPath specified, I bet you. Yes, we do. So wait, do I always need to have an RPath there? So, okay, just a hunch, but I guess if I did this and then I do it this way, no. And that would work. Okay. What would actually... I wonder, what would actually Apple's Clang do in this case? This and then foo. Right, okay, so this is the way we create dilibs. That might be wrong or actually not consistent. So this is fine. No problems there, so let's try and create the dilib. Shared. So actually from now is, yeah, 1:15. Load dilib now. Huh. Aha. Okay, so it actually... So this is interesting. I wonder if... What if we did ZXCC instead and then shared? And then again, so just swapping in. Yeah, we also do that. Okay. Yeah, I wonder, maybe that's a mistake. Maybe we shouldn't do it this way. But then how do you actually build, I wonder, how do you build a shared object with just an RPath? No, I don't want RPath like this, that's stupid. Right, let me have a look. Let's have a quick. Or actually, maybe in the manual. Right. Yeah. So add path to the run path search path list for image being created at runtime. DLL uses the run path when searching for dialects whose load path begins with at rpath. That's great. We don't want that. We actually want to. How do I specify for the dilib to have rpath and the actual load path for the loader to load it at? Search paths maintains blah blah blah. Then yes, go ahead and your search path. Actually, we need to add the dash z as well. Dash z as well. I don't have that. I don't think we have that in. Preload. No, that strip, nothing like this, no branch islands. Oh yeah, I actually need to, I'm definitely gonna stream this, it's gonna be fun. So on ARM64, we need a thing called branch islands for, if you're building like a big binary, it can happen that you need to jump to a location that's beyond what the instruction set architecture is able to do. So you need to create the so-called branch islands, kind of like like jump tables, I guess. You jump to a cell in the branch island, and then you do like a trampoline from that to further on. This is gonna be fun. Like, this is not there yet, so this is a hard error at the moment in ZigLD. And this is gonna be a little bit more, well, you need to figure this out if it needs like an additional pass, because what is happening, this obviously needs more space pre-allocated in the text section. And what currently happens is that we do a two-pass approach of actually gathering data about how much what the maximum is for the entire binary, like in terms of section sizes, and then we allocate. But this might be a bit more, this might complicate things a little, which is okay, I guess. Huh. Yeah, that's not very helpful. So let's see what Uncle Google has to say about this. Right. That's the install name tool. Yeah, that's fine. We actually did that already. Okay, so Microsoft folks say that is that Microsoft, yeah, should be the default, which we already do anyway. Oh, this is the install name. Oh crap, okay. So actually, yeah, I wonder what the what good default would be. So to actually make this work here, Clang, no, and then actually install name. Do I need to pass it like this? Install name would be, I think, I need to spell it all out. Right. So why is it complaining here? Let's have a look. So maybe without. Oh, okay, there we go. What if I do this? Oh yeah, that's shit. So you have to you have to lay it out. Okay. So wait, I could actually do this. And then I could probably do, no wait, on main C. No. Yeah, but this, and then this is not gonna work. Okay. Of course not, because you can't find, because, oh my god. So what, and then, that's crap. So you have to spell out the entire path. And God forbid you make a mistake. Okay, so then if I do this, then this is gonna work out fine. Yup. If I get rid of the art path, then this is going to cry. Okay. Right. Oh, hi, Retazigit, I don't know how to pronounce that, sorry. Yeah, so I'm trying to work out why, so basically, this is to do with runtime paths for creating dilibs on macOS. So by default, if you build a dilib on macOS, let me show you, there we go. And if you just specify that the bare minimum, shared, like the dash shared, and that's it, and then the name of the library, what you get is a library with ID load. So basically this load command is responsible for basically setting up like the timestamp, current version, compatibility version for linking later with binaries, and also the name what this library is available under, and it's just foo.dilib. This is a relative path. So if you do that, then it's fine. If you just then link, just main, like this, right? And then this is gonna work fine, perfect. But what is happening by default with Zig, I think this is with CC2, if we do that, then we actually make it a little bit more bulletproof because we do this magical string at our path. And this basically says that, you know, it passes information to DYLD that it's available under any runtime path that the user has specified in the binary. So if we just then build, if we then build main C and, oh my God, and we try to link with foo, and this is not going to work because it expects an R path, so you have to pass in whoops, like this. No, okay, so this is a linker thing specifically. R path like that, and then what then the linker is doing is adding wait, let me find it. Wait, what did I open up? Not the foo. In the binary, it adds this magical load command called rpath with the path, that the relative path for here. And because of this, we can actually run it now because it's going to be able to find the dynamic library. I think I had it open somewhere here. Yeah, so these are like run path dependent libraries basically. So this is so that you're not worried about, you know, you can then move the library around easily. You don't have to have it in the same folder. You can actually have it somewhere else. If you don't do that, then obviously you have to have it precisely where, you know, so that the relative path is correspondent to what you know what you did when you created it. And what I'm working on here is I'm trying to figure out basically for this test case, which is exactly trying to do that, whether Zig's default behavior actually adding rpaths is fine or not. And I'm on the fence. I mean, I think it's okay to mimic the same behavior with LD64. You need to append this flag install name and then spell out the entire path, which is just weird. Why would you have to spell it out if you have the -o flag? But whatever, maybe that's fine. And I'm trying to see if this is needed or not. I guess I'll just leave it as it is. So let's tweak that test. So basically we have to the our path, but this is the exe, so I think we need like that, and then our path, I think, or maybe not, maybe actually, I can't remember. Let's have a look. Let's try and build it again. Run test run. Yes, it's unrecognized, is it? Yeah. So for build exe, we don't need the WL. We just need that and that and that. And that should be fine. Yay. Okay, cool. Yeah, okay. I guess I'll just leave it for now like it is, as it is. Let's tweak the test so that we don't dump the commands again. This isn't needed, and I don't think we need to clean up. I can actually clean it up at the moment. Let's get rid of the Y. What did I do? Interesting. And let's run the test again. Yeah, so the big picture here, Red Hazard, is that I'm actually working on the test harness for our in-house linker in Zig. So I'm trying to port as many, I wouldn't call them unit tests, but they're close enough, like, you know, minimal and end-to-end tests. And then, you know, adding different things, figuring out how to do this so that's clean. This is what the tests look like. A lot of actually the test is based on C. There is some Zig here and there as well. but a lot of them are actually based in pure C. So I'm just trying to do this. If everything is properly resolved, I should probably add C++ test too, because C++ also has some special treatment in the linker after all. I actually do it now, but let me figure out. Yeah, okay. Just even a simple one. Oh, because so C is cool for testing like this because it generates like minimal binaries, and it doesn't have anything like, it doesn't add a lot of bloat, or maybe not bloat, but you know, it doesn't. It's a very simple language. It doesn't have a lot of like defaults. So if you need something, you have to add it in, or just use this crazy macro stuff. But I'm not going there. In C++, even if you do some basic stuff, you need libc++ linked in. It can be a dilib. In Zig, we ship libc++ and we build it on the fly once, so that you don't have to have it lying anywhere, and it's actually statically linked. So this adds to the final binary, like you know, size-wise it explodes, and it's actually quite complicated and difficult to look at, find like seg faults, why something didn't get linked properly and things like that. And with Zig, we also have a fairly advanced libstud, and then we have panic handlers and things like this. So this also adds to the final binary that's actually bigger than what you want. And with C, there's nothing. Like, you know, what you see is what you get, which is great for testing because it's super small and it's very easy to eyeball it. So that's why C, because it's super, you know, compact, I guess. So let's try and let's just call it C++. Why not? But that's an excellent question, and the same is with Rust. It also adds a lot of like auxiliary stuff like panic handlers and things. So this, you know, it makes the binary quite complicated from the start. Even the hello world can be quite complex to analyze. Which is not to say I didn't do that. Obviously I did, and I had to. Especially difficult when I was working on the linker in the past, like in the beginning. That was, I think I started in January or February this year, and then like on the traditional one, I got C linking, like basic C linking pretty fast, which was, you know, cool feeling, right? You start off with nothing, and then you're like, yeah, you know, basic C is actually linking. You get a working binary, and then I wanted to link Zig. That was a little bit more complicated. We already had TLS a lot, you know, here and there. So all of the stuff had to be taken care of, and then comes C++, and C++ is still not like, the linker is not able to, for example, handle exceptions very well yet, and I need to look into this. We're missing some stuff like compact unwind info. I need to still work out what the hell this is about. But anyway, for C++, everything just became so much more complicated. You have, you know, the static initializers. You know, you have to lay them out properly and things like this. I was like, whoa, you know, too much info, basically. Right, what do I want to do here? Oh, actually, I think just an executable will be fine. And then I wonder if you can do that actually. Hopefully it shouldn't matter. Yeah, let's do it the nasty way. IO stream. Oh, we can actually have a void, right? Yeah. Main. And then stud. Why not? Right, we have a void, so that's fine. I ate something here. I think, yeah, I did. Don't need that. And then okay. The case is expect stood out. Should be hello world. Whoops. lowercase w, and then the new line character. And I think Zig should, yeah, I don't think we need to specify linking of C++ library here. I think it should be fine like this, but let's have a look. Oh, and on the question why you see in tests, actually I need to add Go as well. I need to add Go. I should probably add some Objective-C, but I need to add some Go. I need to add some Objective-C. Probably not like this though. I'll probably add it as a standalone like build.zig sub project, so to speak. But this is also important because Go is also doing. It's got like an interesting choice for sections, let's say, and then Objective-C has got its own entirely different sections and special handlers in LD64. I thought actually that the sections can be compressed together, but they can't. There are some Objective-C sections that have to stay as they are. I should probably do more investigation why. So all this stuff, I need to add all this stuff. Then I also need to add like linking with actual SDK on macOS, like proper frameworks, probably graphic stuff. So use some Zig SDL as a test case, maybe Sokol Zig and things like this. Right, so this doesn't work. Why doesn't it work? What if I do... Oh, where's target as well? But that should pick... Oh, let's have a look. I think this should pick the inbuilt sysroot that we have, that we provide with Zig. I think it should be fine. Nope. Oh, main mass return end. I thought it didn't. Oh, let's have a look again in a minute. Anything else? Must return end. Okay, that should be it. Yay. Okay, cool. Perfect. So we have C++. Let me actually pull up Ruiz test cases, which are really, really, really useful. GitHub Ruiz hold. We're gonna go to test. And he actually has Objective-C. Does it require SDK here at all? Yeah, it does. But then we have so wait, how does this work? There's 8.0. Okay, just back it up as a static archive. We have Objective-C. So this should actually complain about missing an object, shouldn't it? At link time, I would imagine. Well, we can give it a try, I guess, see what happens. So if we add create case, just call it C, both targets, both. I wonder if I have to like escape the fact that we might need a framework, and if we do, I might need to like have like behind that feature, basically requiring macOS SDK in the path, which is fine. I haven't added that yet, so but let's see. This is gonna be a C source again. Oops. Let's call this was it M? Although I don't think that matters at all. So and then we have, is it import? Yes, import foundation ns object.h. This will require, I think, Objective-C flag, but that's gonna come in a minute, or Objective. Okay, let's have a look. Then we have interface, my class, and a subject. Right, cool. And implementation is going to be empty station. And okay, that's the first one. I'm not going to create a static archive here. I actually need to still add the machinery for actually doing this. So let's do that. Okay, there's no import, just build it. Just int main, if nothing else. Okay, and then do we need link flags? That is Objective-C, but I guess we can just skip it for now and see what happens. Oh, and we don't expect anything, so we just expect this to pass. Let's have a look. It might or might not work. What is slow? Oh, testing, you mean? Oh yeah. So basically, because every single test case is spawning a new user compiler, not even using like we're not hooking up to the actual code. We actually invoke it as we were like doing it by hand on the command line. And it's the debug build of the compiler at the moment, so that if something goes wrong, I can always go back and debug it or have a nice stack trace and things like this. But yeah, so if it's in release, it's gonna be a lot faster. But it's still spawning everything on the command line, so. I can maybe I can try later on, just try hooking it up to actual machinery that's responsible for compilation and so on. That should be faster. But I know there were memory leaks everywhere for stage 1, so I don't know if it's going to be worth it. It's okay, I guess. You don't. We're only going to run it in the CI, and if anybody, you should only run it if you're actually tweaking anything to do with linking. If you don't tweak anything to do with linking, then you know, you don't need to run it. If you're working on stage 2, then there's no point. You have stage 2 tests and stuff. But for me, if I'm like, I've been adding more things to the linker or changing stuff and just, you know, introducing a regression after regression. So this is like required whenever I actually tweak something. So, but yeah, that's a fair I noticed that it's kind of slow. So I might look later why. Maybe I'm doing too many. Maybe I could like do a little bit more cleverly. Maybe I'm allocating too much memory, or like, you know, like too granularly or something. I need to have a look. So yeah, fair point. Let's have a look. Right, okay, so foundation and subject not found. Oh wait, but he was using CC, so that's okay, right. So I think Ruiz tests depend on SDK being installed, but we don't have it. So basically, for that to work, and because we're using target, I would probably need to spell everything out. which would be, I would probably need to write, okay. Let's see if I remember right. So this would be user lib. Used to be user local lib, I think I've tried that way. And then we would have system library frameworks. And this is still not enough because we, wait, no, it's not. Not these flags. Wait, my bad. This should just be the compiler, so only includes. I think it's user include. Right, let's have a look actually. System.zig. I think we have the native paths. That's not. Oh, that's that one. macOS, no. There we go. No, that's not. Wait. Solaris. Oh, there we go. Darwin, right? Yes. Okay, so this is old, and this is old. I think this is old too. I think this is also way now. I think Apple is now using system library frameworks, user lib, and user include. Right. Okay. So we need user include. And that should quieten down the error, but it won't, because we also need to pass in the path to the sysroot. Okay, so this is interesting. This isn't okay. Let's just make this test pass, but on my machine, but this is not going to be universal. We need to be able to do something like, oh, maybe can I like hook up here, like because we need this. We need sysroot, and then we would also need to run on macOS only. This is not going to work on foreign host like Linux, obviously, because XCRun is on a macOS specific utility. But I wonder if this, would that be passed in properly, or would that be passed in like escaped? Because if it's passed like escaped, then that's obviously not going to work. So maybe I should extend this with some kind of like a pseudo, maybe not a language, but yeah, I don't think. Or I could set that requires Objective-C and then actually run that in the test harness. So let's just make it, okay, that might be the thing. So this is the SDK path. Let's just paste that in for now. This is obviously not, it's not going to be like this. This is not going to be hard coded, because that would be stupid. Just for the sake of testing that stuff out here locally, let's have a look at this. At least silences the compiler, that we can find all of the all the headers. And if that's the case, then I think we're gonna also need to do the same thing for link flags. No. Wonder why not. So the same thing. Let's try and do the same thing as before. Actually, the quickest way to debug the tests right now. Just forget about the cleanup. Let's clean up the cache. Try the same thing again. It's going. Okay, this is in. Nope. FB something. No. Oh. No, no cache. I guess whatever. Okay, right. So we have that one down. Okay, so if we do, let's repeat that here. So we have C, and that one should only get Objective-C flag, because this is the only one that needs that. The main.c is fine. Yeah, I think sysroot is in the wrong place. Show SDK path. What? Oh. So it's still the same problem, huh? Oh, we should also have target. Let's not forget about that, because otherwise we actually pick up the sysroot automatically, but that's fine. There's still no problem, no difference. I mean, so. Let's do it this way. Just a.m, but then install an object. Oh, what? What? Oh, because oh my god. So still file not found. Wait, is it local include? No. Oh, it's built up. Yeah. Let's try exe instead. And verbose cc. Ah, what? Why are you complaining at me? So I'm trying to figure out what the. Wait, we have iSystem. There is no sysroot. Why is there no sysroot? Do we even wait? Should be sysroot. Okay. So why the hell? So with this doesn't work, obviously. Crystal. Huh. Hey, Loris. If you have any comments about the quality of the stream or if anything can be improved, Loris, just let me know. Because it was, I'm gathering feedback as I'm going here. Because I couldn't, I didn't know how to check what's on the other end in an easy way. So a lot is just, like put up with a duct tape effectively. Run, show SDK path. I am going to die. What the? Okay, so how? Why? It's not accepting the sysroot? I wonder. No, framework, small subsystem. Sysroot, that's not only a linker path. Oh, wait, no, wait. Okay. Some text is going behind. Wait. Camera. Behind my camera. Oh, right. Yeah, I need to get Bork. It's on my to-do list. I definitely need to do that. So, and I was planning of actually having it here, above my max shot. So I'll definitely I'll work on it for the next stream, for sure. But yeah, thank you. Yeah, that's an excellent suggestion actually. So anybody's got any ideas for the sysroot? I'm kind of lost. Let me try and maybe there's an answer in one of the no wait, that's the iOS example. Vertical split. We have a vertical split. Oh, you mean like a horizontal split? Like this, you mean? Okay, don't worry. Yeah, me too, actually. Okay, right. Let me try and. So what is happening here? Okay. Oh, that is the I system with sysroot, but that's ridiculous. It shouldn't be. Or was it I with sysroot? I think it was I with sysroot. Yeah, but that's exactly what I'm trying to do. I'm trying to basically, if you have an explicit target, like we do here, you're in the cross compilation mode, so you have to spell everything out yourself. And that's exactly what I'm trying to do for testing, because for the linker tests, everything will be explicit, not assuming the host, right? We want to be able to actually run them actually build, execute the linker test, and then if it's possible to run, we can also run on the native host. But the point is, we want to build it anywhere. And I'm trying to figure out what the hell am I going wrong with this stuff. Ah, right, okay. Yeah, so the test actually, the testing harness is basically based on stage 2. So everything is with an explicit target. And we have the targets here. We have the Mac OS x86-64, and then we have Mac OS ARM64. And I don't understand why it just refuses to build. Because the sys should work. Maybe let's try XCC. Is it even sysroot? Yes. Okay, show SDK path. Like 8 of them, and then I'll be Objective-C target. Okay, still have fun. Okay, that's good. And now will be user include. Is there a space here? No. Okay, what am I doing wrong? What about just, that's your suggestion, Loris. Like, screw the fact that we have a target. Let's do it. Okay, at least we went further. Oh, is that actually Objective-C maybe? Next. Red. Objective-C. No. Oops. Okay, in that case, I go for broke. I'm gonna fix. I haven't actually fixed that the repo yet. Oh, I don't have it. iOS. Let's do that. Let's see if it's actually gonna build. I don't think it's gonna build, or maybe. Okay, let's leave this. Zig iOS example. Some things have changed. And this is for the upcoming 0.9 release, which is great. I was meant to do that, but I haven't yet. Oh, built-ins. That's built-in. And then music build. Hey, okay. This is the same error. That's fantastic. And why is that? Wait, we are setting the target. What's the default target? I don't have a default target. Oh wait, okay, yeah. That's obviously not gonna work because we're trying to build something specifically for iOS, and that's not present on macOS because we're not targeting the Catalyst, I think they call it. Right, actually we can do the simulator. That's the easiest. What? That's the target. Okay, because we are using target, this is going into the cross compilation mode. So I think this is fine. But we're still gonna miss the sysroot, I believe. Right? Yes. Oh. So, okay, install file later. I think we need to add an option. Default step depend on options or opts. Was it just add options? Wait, let's have a look. So basically what we're trying to do now here is expose sysroot option, which will be needed. Just a sec, which will be needed to actually to properly hook up the include path and everything else. And we'll see if it works. Maybe it doesn't. Maybe I broke something. So we'll need to fix that too. Zig, how do we add options here? Release options, install. Yeah. Ah, right. Packaging miss build options. Fair enough. Oh, do we care about this though? I don't think so. Help. Let's see if there's. Maybe this is already exposed. Yes, it is. Okay, excellent. So I think fancy that. Okay. iPhone simulator cannot be located because it's not iPhone simulator, it's maybe I didn't have it. Yeah, I don't have it. Well, that's annoying. Okay, anybody's got any projects that don't? Oh, I know. Maybe Pacman. Let's. Oh, what? Let's pull the latest. Is that mine? Need to do fetch from upstream. Upstream master. Main. Okay, awesome. Nice. Okay, you can actually push it. Right. So maybe with this we're gonna have more luck because I am not prepared. I don't have Xcode installed. so I don't have any frameworks and headers for targeting iOS. So Zig iOS example is out of question at the moment. So let's try and go into the Pacman project. Wait, build.zig. Let's have a look. Okay. What? Why do we have system linker hack? Should be a version that actually targets master. Zig 0.9. Okay, excellent. Let's check this out into a branch too. Oh, we already had it. Interesting. So let's just rebase. Okay, cool. Right. Come on, push. Oh my god. I think it's my Wi-Fi basically being crap. Abort. Oh, because we have it opened. Right, yes, excellent, there we go. So we had so-called. Okay, if it's not Darwin, then we need to add these manually, but if it is Darwin, then this should build. So okay, so that does build. What if I do? Actually, let's go for broke. Let's do that. Okay, so now we don't find stuff, which is awesome. And that is because this should not be here. Or actually, let's leave it there. Or, yeah, okay. Let's comment that out. Let's try again. Interesting. Oh, because we don't have the sysroot. Right, yeah, okay. So, sysroot. What? Okay, this is insane. Oh, I think Loris. Okay, yeah, I should definitely do that. I think there was a way to do it automatically. Loris can prove me wrong here. I mean, for sharing a link on Discord too. Was there a way to do that? Like, a bot would ping everybody or something? Maybe? Maybe not. Oh, okay. So basically I would have to, okay, so Loris is saying that Suzy doesn't post the link automatically at the moment. Okay. No, it's okay. I'm gonna have to go in a minute anyway, so, but I'll remember for next time. Basically, I'll try to do a stream tomorrow or something. It will put. Oh. Wait, am I in a? Okay, so Susie is online, but I don't see myself there. Maybe I don't have Zig in the title? Not every day, but I'll try to do a couple of days just to basically warm up, see how it goes. I was hoping to finish the test harness today, and tomorrow we'll do something more interesting like. Oh no, I don't want to do streams every day from now on. No. But I'll try to do like every second day or so. Anyway, I wanted to finish the test harness today. Okay, your title should be fine. Oh, okay. Is that because I'm on the M1 or something? I'm in the. Oh no, oh wait. I am. Streamer mode is enabled. See, that's what I mean. It's so complicated. Like actually writing code is easier. Streamer mode enabled. The hell? Okay. Magic. It's like black magic. So yeah. Anyway, so I wanted to finish the test harness. Thank you, Laris. Yes, I do have a ton of streamer viewers. I hope they're enjoying the show. So far, it's not been very flashy or anything like this. I got stuck on freaking Objective-C. Oh, I can try restarting Discord, yeah. I'm actually using... So for Discord, I'm using the a beta app because Discord is finally catching up with everybody else, and they're working on a universal app. So this one is actually a native, apparently, to ARM64, so M1. Yeah, that doesn't work. It does say, like, there's a banner at the top saying, like, streamer mode is enabled. Stay safe, friend, so... I think it did pick up. I mean, it might be the beta. But, you know, it's the only standalone app that actually works in M1, like, the actual stable one, you know, the one that runs via Rosetta is unusable, it's so slow. Yeah, I can try it out. I can try it out like later on, like see what you know what actually is happening. Yes, I'm using OBS, correct? Yeah. I'm using OBS pretty much the way you helped me set it up, almost. Although we did it on Linux, I just I backported all the settings to macOS here. Oh my god, yeah. So anyway, maybe. Yeah, I wonder if just to start, like, I wonder actually. Yeah, wait. Let me try something, because so for example on NixOS, restarting Discord is not as simple, because it's got stuff floating around. What the hell? Oh, was that just a grep? I guess so. Must have been on NixOS. It's not that easy. Like if you close the app, it's still running in the background for some reason. I don't know that. I don't get it. But I guess here it seems that it's fine. Yeah, it is starting. Let's see, one more try. No, I don't think. Yeah, something is bugging out. You know what helps nowadays in macOS, right? It's the restart. That's a bad joke. Okay, yeah. So I'm gonna. Oh yeah. Exactly, Loris. Yes, Loris says that he wouldn't be surprised if it's one of the things that broke when going ARM native. I'm pretty sure that's it. Oh yeah, like they will fix it for sure at one point, sure. But you mean like in a year, 2, 10? You know, they've been taking their time to actually release even the beta stuff. Or maybe I just should have a look. Maybe they have a stable one now. You know. I might have better luck on Linux. So yeah, you can definitely expect that at some point this week, I'll hopefully. I'm really eager to start to restart my work on x86 64 backend. Yeah, like a poor $15 billion startup. That's Discord for you. I wanna restart my work on x86 64 backend and also on ELF linker. So I'll definitely stream that too. And this should be more fun than this because I don't know why I got stuck on Objective C for some reason. I have no idea why and what I'm doing wrong here. I don't know. I need to. Yeah, thanks, Lotus. Yeah, it's been great. I mean, this is it's the first stream, so things might be going, might not be the best and stuff. Oh, by the way, how do you guys like the feed from the camera? So that's the Lotus knows that this is the Nikon ZFC that I got like this summer, I think. And I think it's so far it's been good. The only annoying thing is that you need to have the battery charged, and like actually you need it charged, like enough charge to actually get it going. You need to have it plugged in. Oh, okay, wait, and you need to have it like in, and then let me just do that. I'm gonna call this the scene mugshot. Why not? Capture device, icon. Comlink. There we go. So yeah, so I'm using you probably have it as well, Loris. I'm using the Comlink 4K, the USB dongle. And yeah, and the funny thing about the camera, you need to have the battery. It has to be charged at least a little, and then you in order to have it going and not overheating, you just plug in the USB-C cable and it charged, and it's charging, and without the battery actually going flat. But you still need it in, and I just don't get it. I don't know why Nikon did it. I think they must have some kind of a, the way it's designed in the circuit, they must have some kind of an off switch. Basically, if you don't have the battery in, then it's not going to start, even if it's plugged into the power source, which is just weird. But I won't complain. It's pretty cool. Like it's actually running cool. It's not overheating or anything. So. Oh yeah, and I changed the I also changed the microphone setup. I think this way is better because when I had it like from the top, I had problems in like seeing stuff in the middle of my screen. I would have to go like this. So I think having it on the side is actually better. I think that's what you do as well, if I remember correctly, and I think Andrew does the same thing. So Oh, and I stole your music, obviously, Loris. Thank you for that. Although I need to tweak the the levels too. But yeah, thanks for the link. It's actually very pleasant. Even though it's lo-fi, it's very pleasant to work with. So, oh, and these headphones are they're like yours, Loris, like just lower grade, but still they're meant to be they're meant to have a flat response, meaning that you can definitely hear the lo-fi. Like I can actually hear it. So yes, I definitely, yeah. So Laura is saying that I'll need Bork. That's exactly what I need, and I'm actually gonna get on to that today. I think after I fix the or look at Objective C stuff a little bit more, I'm gonna get Bork. So I'll definitely leave you a message if I have some problems with it or something. So thank you. Oh, okay, I'm gonna have problems with pork. Thank you, Loris. Yes, I'm looking forward to that. Hey, I'm gonna drop a PR to if I come up with a fix for something. So it'll be good. How would you like me to work on Borg while streaming? That would be cool, right? Yeah. Ooh, for that we could definitely. I mean, oh, that's a great stream. Working on Borg. If we had stage 2, imagine, and we had hot code reloading, you could work on Borg and then while streaming and then do like on the fly reloading when it's actually running to see the changes. Oh, this is a great advert material, man. Yes, we should definitely do that. Oh, glad you like it. It's good, right? We could totally do that. Oh my god, this is it. We should definitely. Okay, I'm sold. Like so basically I need to do this, I need to advance ELF a little bit more, and then I also have to do a bit more of x86-64 backend. But after we're done with this, we can totally pull this off on Linux with ELF. Yeah, and then we could use Borg as a test case for stage 2 too. I think that should be doable. I think even in a couple of months. I'll need to like sit with Andrew a little bit on the actual hot code swapping with ptrace, but it's definitely going to be easier than trying to pull that off on macOS. On macOS, I think I'll need to sit and basically read through the kernel sources to see how the heck can I disable stuff. Ah, right, okay. We have async await. Okay. Could we like disable async await in Borg and just make it um can we could we just disable it and make it synchronous just for testing, or not really because it's getting updates? Well, I wouldn't say 90%, but we're getting there for sure. Especially now that front end is very advanced. The main missing bit for hot code reloading is x86-64 backend, like CodeGen. But this needs a bit more love, and I already started doing stuff for it. Okay, it doesn't need it directly. Okay, because we could. I mean, we'll see how it goes, right? But if we could like do some rework in a separate branch for Borg with async code just to show off this hot code reloading stuff, and then get some updates from Twitch, even if it's synchronous, even if it's like laggy and jittery, that would be awesome. That would be really neat. Um, okay. Anyway, folks, that's gonna be me for today, I think. I need to go and help out with my daughter for a little, and then I'm gonna be back to do more coding, but probably the lighting conditions outside will be a bit worse in the evening, so I'll probably keep streaming, uh, you know, closer to noon my time. So thank you, Loris. Have a nice day too. Thanks, guys. Bye bye.